Hey everybody, this is Mrs. Fry. I hope you're ready to learn some more math today. Yesterday we learned about operations with functions, just looked at adding and subtracting the functions together, and today we're going to do some multiplying problems as well as learning about what a composite function is. So as you can see, I have the same exact four functions from yesterday: a of x, b of x, c of x, and d of x. And we're just going to start out by multiplying. And what you should know is we're basically just going to be setting up our own problems and then performing the operations following all of the same rules for simplifying polynomials. So, oh, I have no idea why that just turned red. Anyways, let's just go ahead and set up our first problem. D of x times b of x would look like this. We would put x to the third plus 1 times 3x minus 4. Actually, I think I'm going to move that. I'm not going to have enough space if I leave it there. Let me move it up here. Okay. So what we're going to do on this problem is we're going to use the distributive property. You might have heard of the word FOIL before. FOIL stands for first, outer, inner, last, and that's basically what we're going to be doing here. You can draw some arrows to kind of help you out here on which way to go. I'm going to use my rainbow pen because I think it's cool. So this is multiplying first, outer, and then inner, and last. Okay, so let's go to multiply in that order. X to the third times 3x would be 3x to the fourth. And then x to the third times negative 4 would be negative 4x to the third. Then we're going to multiply the inside terms. 1 times 3x would just be plus 3x. And then 1 times negative 4 would be minus 4. Then the next thing you would have to do is just look to see if there's any like terms that you can combine. And on this problem, there are no like terms to be combined. So I'm just going to put a box around it. That is my final answer. There. Okay, next problem, same thing. A of x times b of x. So let's go ahead and set that up. A of x would be 2x plus 5 times b of x, which would be 3x minus 4. Okay, so we're just going to go ahead and distribute here. Let me just draw my arrows. First, outer, inner, and last. So 2x times 3x would be 6x squared. 2x times negative 4 would be negative 8x. 5 times 3x would be 15x. And then 5 times negative 4 would be negative 20. Now this one does have like terms that can be combined. We can combine these x's in the middle. Highlight those in yellow. So my answer is going to look like this: 6x squared. And then negative 8x plus 15x is 7x, so put plus 7x, and then minus 20. And that's it. Put a box around it. Now let's talk about composite functions. A composite function is when you have a function written inside of a function. So you can see my problem here. I have c, parenthesis, d, parenthesis x. How do we even pronounce this? I would say this is c of d of x. C of d of x. So basically what you're doing here is we've got c, and inside of c we're going to put d of x, which is x to the third plus 1. So then I have to go back up to c of x, and I see that c of x is x squared minus 2. So that means wherever there's an x and c of x, I'm going to put the x to the third plus 1. So it'll look like this: x to the third plus 1 squared minus 2. Okay, this is going to end up being a much bigger problem than I thought it was. Okay, and the reason for that is because now I have to expand x to the third plus 1 and square it. So it's going to look like this: x to the third plus 1 times x to the third plus 1, and then I've got that minus 2 down there. I'm just going to move. What did I do? Just going to move. I wanted to lasso this. I want to move this down. There we go. Okay, so now I have enough room to finish working this out because now I need to distribute. Use the FOIL property that we just did on those last problems. First, outer, inner, last. So that would make this x to the sixth. X to the third times x to the third would be x to the sixth. X to the third times 1 would be plus x to the third. 1 times x to the third would be plus x to the third. And then 1 times 1 would be plus 1. And then I still have this minus 2 at the end. Okay, so I guess that wasn't that bad. Now I just need to combine my like terms, so the x to the thirds can combine. And then you can also combine the 1 minus 2 at the end. And then that will be it. So my answer would be x to the sixth plus 2x to the third minus 1. Because 1 minus 2 is negative 1. Put a box around it, that's your answer. And then we've got one more example for the composite function. It says a of b of x. So let's see here. A of b of x. b of x is 3x minus 4. So then I'm going to take 3x minus 4, and I'm going to put that in for x in the a of x. So that's 2 times 3x minus 4 plus 5. Okay, so everybody see that up here? This 2x plus 5. I took out the x, and that's where I put the b of x, is in for that x. Okay, so now I'm just going to work this out, distribute the 2. So this would be 6x minus 8 plus 5. And then the last thing you would have to do is just combine these like terms here, negative 8 plus 5. Well, that makes this 6x minus 3. And that's your final answer. Okay, so the composite functions are kind of confusing, and I did throw out a really kind of difficult example for the first one. I guess I should have worked out my examples in advance. But anyways, let's look at our 2 homework problems, just like yesterday's. I've got the same exact 4 functions, but now I have a multiplication problem. I want you to take c of x times b of x, and then we have a composite function, b of c of x. And as always, text me your answers on Remind. And then don't forget, oh, I spelled Remind wrong. Don't forget to work on Alex too. Okay, because today is technically the last day of this school week because now we're on spring break. So remember to be working on Alex, 1 topic per day. So you should have 3 topics done for this week. And I hope you guys have a good weekend. Bye.